Hiya! On today's episode of Preaching to a Seven, we'll have a look at a classic identity for complex number, as well as an intriguing inequality to prove. Let's kick us off with part one. This is a routine question, so you shouldn't be spending too much time on it. It always starts in the same way. We're interested in sine of 6 theta. What happens if we raise z to the 6th power? We would get, on the left-hand side, this expression. Using the Marshall theorem, we also get this result. Therefore, sine of 6 theta is simply the imaginary part of this complex number. So let's expand the left-hand side. For the rest of the proof, I am going to use C for cosine and S for sine. You are allowed to do this. It will just save you a lot of time. So we consider C plus IS to the power of 6. This will give us C to the 6, 6C to the 5 IS, 15 cos 4 IS squared, 20C cube IS cube, 15 C squared IS to the 4, 6 cos IS to the 5, and then S to the 5. I squared is negative 1. I've underlined all the terms that contains I. These will form the imaginary part. Factorize the cosine out. Using the identity sine squared plus cos squared is equal to 1 to express the entire thing in terms of sine. Just be very careful and make sure that it is the same as the printed result. Therefore, sine of 6 theta is equal to cos of theta times 6 sine of theta minus 32 sine cube plus 32 sine to the 5. So this is the end of part A. A pretty straightforward proof. Part B, however, this is where the fun begins. So you're asked to consider sine of 6 theta divided by sine of 2 theta. So let's do that. We can factor the 2 sine theta out of the brackets because that would leave us with 3 minus 16 sine squared plus 16 sine to the 4. We're interested in doing this because sine of 2 theta is 2 sine theta cos theta. So that is very convenient. The expression becomes this guy. Now, how can we show that this is between -1 and 3? One strategy is to complete the square. If I am going to complete the hidden quadratic here, I would need to add 4 and then subtract 1, because this is 4 sine squared of theta minus 2 squared minus 1. Now you might be asking, why are we doing this? This is because this will now allow us to find the range of this function. Sine of theta is always between -1 and 1. However, we're given that sine of 2 theta must not be 0. This means that sine of theta is not 0 or cos of theta is not 0. Oh, sorry, and. If cos of theta is equal to 0, sine of theta is equal to 1. Therefore, sine of theta must not be equal to 1 for this to work. We can also deduce that sine of theta must also not be equal to -1. Now we'll consider the bounds. First, we need to square the sine. Multiply by 4. Minus 2 squared subtract by 1. And this gives us the required inequality. This is tricky for 2 reasons. One is that most students would not think of using a valid method to find the maximum and minimum value of this. 2 is the additional restrictions required, as sine of x or sine of theta cannot be equal to 0. This is quite a demanding proof and pretty hard to nail it right. So if you manage to get it, give yourself a pat in the back. Great job.